What's going on, everybody? Mr. Diamond here with the second attempt of this because I used the wrong notes because, I'm Mr. Diamond. That's what I do. We're going to be doing Chapter 1 of Physics. This is all about 1D kinematics. And obviously we're going to start off with the same stuff we normally do in these classes, which is we need to identify what exactly we're talking about here. So we're just going to get a little bit of background into physics itself. First of all, what is physics? Physics is the branch of science concerned with the nature and properties of matter and energy. The subject matter of physics, distinguished from that of chemistry and biology, includes mechanics, heat, light, and other radiation, sound, electricity, magnetism, and the structure of atoms. Now, you might be thinking that last part especially is weird because structure of atoms seems a lot like a chemistry thing, and it is, but they care about slightly different things. It's actually was physicists that did discover the structure of an atom, but understanding the concepts. If you remember when we got kind of far into advanced chemistry, if you took that, we talked about the energy being released in reactions, and eventually, if you get high enough into chemistry, you start talking about the energy level of electrons. You may remember some of that from Gen Chem when we talked about how there's like the SPDF orbitals and the shapes they're in, and they have different energies. All of those energies and the power exchange and the energy exchange and all of those changes are things that physicists care about. And actually, physics itself is kind of one of the root sciences, and if you dig far enough in chemistry, you'll hit physics. You may remember, I may have done this before in some of the other classes, but if you start at biology, if you dig through biology enough, you'll eventually hit chemistry. If you dig through chemistry enough, you'll eventually hit physics. If you dig through physics enough, unfortunately, you will hit math. And mathematics then becomes kind of the foundational thing of our universe in some ways. We're mostly going to be focusing on the first part there, especially mechanics. Mechanics is the study of motions of objects, which is kinematics, and the related concepts of force and energy, which is dynamics. You can basically think that kinematics is how they move, and dynamics is more of the why that they move. We'll do kinematics first, and then we'll eventually start getting in Newton's laws and talk about the forces a little bit. Mechanics can include a lot of different types of motion. What we're going to focus on most is translational motion for this section in this part of the class. Translational motion is the motion of an object that occurs without rotation. There will be no spinning and no spiraling, at least for the first part of this. If you've ever done any translations in math classes, that term probably makes sense to you. One final base concept that I do want to make sure we're familiar with before we get into actual physics is the idea that is the frame of reference that you're referring to. The frame of reference is the background of an object from which you are assumed to be at rest and in a fixed position. It also helps to determine what it means if a value is positive or negative, because in this class, most of what we're dealing with, positive and negative don't mean above zero and below zero. They'll actually mean some slightly different things. And if you're like, Diamond, I didn't sign up for math to get completely changed for me, don't worry. It'll make a lot of sense when we get there. The definition of frame of reference is a bit wordy, so let's actually explain it with a question. How fast are you moving right now? Well, I guess that also depends on exactly where you're at. If you're at your house, you may be like, well, I'm sitting still. But if you're in your car for some reason, don't listen to this in your car. You should focus. Drive safely. Turn this off. I don't know why you're listening to this. You might be on the treadmill, I guess, in which case you might be thinking you're moving at a different speed than you are. But really, that question depends on a lot of things. You might be sitting still and you think you're not moving at all, but that's based on the frame of reference of just you. From the perspective of someone sitting outside of the Earth or looking at the Earth as a whole, well, the Earth rotates at like 460 meters per second. So you, even if you're sitting still, are actually moving at approximately 460 meters per second. You're just rotating the Earth. Now, that's another perspective, though. If you go zoom out from someone looking at the solar system as a whole, the Earth is orbiting the sun at approximately 29,700 meters per second. So actually, from the frame of reference of someone that far out, you are moving, closing in on 30,000 meters per second right now, which is pretty impressive. You're like super fast. For a more relatable reference, though, think of you're sitting on a train. In the train, you feel like you're sitting still, but outside the train, you're moving at whatever speed you are. Or if you're in a train and you're walking and you feel like you're walking at 2 miles per hour or whatever while you're walking, outside the train, you're going to be moving much faster than you feel like you're going inside the train because the train is moving. So that's kind of the background stuff that I just wanted to make sure we got through. I know this is a really short video for the background information, but I'm trying to keep it as to what we would probably have actually gotten through in class. So this is all I got for you for this first day. We'll be hitting quite a bit more of the actual stuff that we care about tomorrow in the video for section 1, the basics of motion. I hope this makes sense. If you have any questions, you can leave it in the box to the side. You can leave it as a comment on this assignment, or you can just send me an email or try to get into one of the Zooms. Email is usually best, but when I'm around, I'll answer the Zooms. Hope you guys have a great day, and I hope to see you hear from you soon.